Hello everyone, I'm David Holmes. I'm with F5 Networks, and we're going to do a lightboard video today about SSL visibility. What we want to build is the ultimate passive inspection architecture, specifically around decryption. So I'm going to build you a story and show you what we have built and tested for one of the world's big retailers. And this is about as advanced as it gets, but I'm going to try to simplify it for all of us, all right? So I'll just kind of start with how we got here. Here's a user, right? They're out on the internet, and they come into the data center, right? And so I'll draw kind of the old way everything worked. Pardon this little jag here. This will be explained in a moment. But they would come down into the data center. They all go out to some applications. So we'll maybe call it App 1, App 2, App 3. And maybe these are even their different subdomains, right? So it's app1.com, app2.com, app3.com. Right? So this is how things worked in the very old days when it was just HTTP. You're going to your browser, coming in, you read a web page, it's not encrypted at all. That's how it worked in the old days. Now, at some point, people started getting malware and all kinds of malicious traffic, and they thought we need to be able to inspect that traffic. And they also needed to do analytics and see which pages are better than other pages. So what they would do is take a copy of this traffic, send it over to a switch, and there would be a tap here. Let's draw a little tap, right? And then a packet broker. We'll have the arrows going the other way just for effect. Packet broker. And then this would send the traffic out to, say, your intrusion detection system, your analytics, maybe it's T-leaf, analytics, and then like a packet capture, right? But you could hang any number of devices off of here, right? And this is your passive inspection zone. Let's make it a zone. Okay, cool. Now in this particular retailer we built this for, they have very, very strict controls around this, this area here. Who can get in, who can see what. But getting back to our story. All right, so this was the state of the world for a while, and then everybody became to understand we need to encrypt, we need to at least encrypt the traffic between the user and the data center, right? Because we can't have people's credit cards being seen or their usernames or passwords for banks. So they would, of course, use SSL or TLS to encrypt everything. This has caused some issues because, right, everybody has to have each of these applications has to have a key associated with it. This isn't anything new, of course. Oh, my keys are terrible, I'm sorry. But then all of this stopped working, right, because all of this traffic was encrypted, right? And so this was RSA. I'm not sure where I'll put it, I don't know. The RSA certificates. One property of RSA, though, is you can share these keys to any other devices that need to be able to decrypt the traffic and be able to look at it. So these guys would each get a copy of the key, and now they can decrypt the traffic. Traffic is encrypted all the way through here. There's no unencrypted traffic on the network. Everybody's happy. Everyone's be able to see the IDS, the analytics, all that stuff is working just fine, right? Okay, now fast forward till about 2013, people have figured out that encrypted traffic can be recorded and saved, and then later forward in time, if somebody gets a copy of the key, they could come back and decrypt it, right? That is a property of RSA that people are trying to solve with something called forward secrecy. So forward secrecy is a solution to what happens if somebody gets a copy of my key later on, either through Heartbleed or they send a spy or maybe you accidentally leak keys. That happens, no shame. If you accidentally do that, although try not to do that, the integrity of the data that you've been encrypting this whole time could be recovered if somebody gets the key forward in time. So they've been solving this problem with forward secrecy, which basically adds another handshake on top of RSA So we'll write these as PFS, right? And it almost like creates ephemeral keys such that if anybody retrieves this key, they can't decrypt the traffic. Only our smiley face user and the other endpoint can decrypt the traffic, right? Everything sound cool? What's the problem? So what's the problem? Well, if only the two endpoints can see the traffic, can decrypt the traffic, how's the IDS supposed to work? How's the analytics supposed to work? How's the packet capture supposed to work? All of that stops working, which is perhaps an unintended side effect of forward secrecy. Now, the reason this is going to become so topical is there's a new version of TLS coming out, TLS 1.3, which has only forward secret ciphers. Right, I'm just going to write forward secrecy here. Perfect forward secrecy. I hope you can read my scrawls. Looks good from back here, though. All right, so TLS 1.3 only has forward secret ciphers, so none of this is going to work, right? The actual financial community brought that to the attention of the IETF committee. The IETF committee decided, for their reasons, not to allow, say, RSA or existing ciphers that can support this kind of architecture from working. So what's the solution? How do you fix this, David? All right, this, you can fix it, of course, with an F5, because we have been doing decryption for years and years and years and years, and we're quite good at it. So now, the solution to this is you have your F5. See, you now understand why this is here, right? Because this is now an F5 box. We will decrypt it here, basically stripping off the forward secrecy. We can then send it over this way toward the switch, or actually, here's the kind of a magic part here. We're using route domains to send it to ourselves, right? So this is route domain 20. We're just targeting ourselves on route domain 10. Okay, so it leaves the device, goes out to the switch, comes back to us, encrypted with RSA, right? The tap is here, so the tap can take that traffic, send it over to all of these guys, and they can all decrypt it because they have the RSA key, right? So basically we have taken forward secrecy, stepped it down to RSA, that enables all of this stuff to work. And then for this particular customer, they wanted us to re-encrypt with forward secrecy here, which is why I'm calling this the ultimate passive inspection architecture, because this is about as much encryption as you could possibly handle. And as a matter of fact, it's only possible because if you have an F5 Viprion, right, that's one of our chassis devices, the new blades, the 4450s, support elliptic curve in hardware, and elliptic curve is the elliptic curve DH, ECDH, is the #1 forward secret cipher. All right, so all of this works, and there's no unencrypted traffic on the internet. You can still use TLS 1.3 to talk to the users, right? And to the outside world, it appears you're TLS 1.3 compliant. Plus, if anybody's recording the traffic in between here, they won't be able to decrypt it, even if they get a copy of the key. And there's another benefit, speaking of keys. For example, if all of these three were different subdomains, they might all have different keys, okay? So you might have each of these are different keys, and then each of these devices would have different keys. So there'd be a count of 3, right? Because I've got 3 applications. And you might say, well, 3 applications, who cares? I got to copy 3 keys of these other 3 things. What if you had 100 applications? Or what if you're a hosting provider or an MSSP and you have 10,000 applications on behalf of 1,000 customers? That's keys you would have to have on each of these devices. With this solution, since we're doing all of that stuff and managing all those keys, we use one single RSA key here. And so all of these guys don't have to do all that. Every time you add an application, you don't have to add a new key. You're just using the key that the F5 is using, right? So it's sort of proxying all those keys down to 1. All right, so Now you might think to yourself, all right, David, I don't necessarily know if I need the forward secrecy all the way back here. And in fact, we have several customers who want us to do this kind of thing and just send it right through here. And in that case, all of this is basically the same, except there's no decrypt here, right? And then there's no re-encryption there. But that all still works, and there's no unencrypted traffic on the network. So now that is the ultimate passive inspection monitoring architecture for SSL visibility. Thank you.